So the Pythagorean theorem has to do with side lengths of triangles. In order to understand that, I'm actually going to start off by showing you some squares. So right here we have square A, square B, and square C. And if you think about square A, each side length is A, isn't it? And right here we have A. Square B, we have side lengths B, 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 and B. Square C, we have that C, this C, this C, this C. And we know that they all have to be the same length because they are all squares, correct? So since we know they're squares, we know that all side lengths are the same. Now, if we know that this side length is B, then we know that the area of square B is B squared, because in order to find the area of any square, you take and multiply whatever side you have the length of by itself. So we'd say B times B, or B squared, is the area of square B. Then we would say for square A, we would say that's A times A, or A squared. That'll give us the area of square A. Then we get C times C, or C squared, will give us the area of square C. Okay. So what I'm going to tell you now is that the area of this square and the area of this squared, when you add them together, is equal to the area of this squared. So the area of square A, the area of square B are equal to, when you add them up, the area of square C. I'll show you an example. So I have areas of 3 squares there, and I put them in a way so that I have a triangle in between. So the area of our little square there is 9. So the area of the little square, if that's 9, what does that mean each side length has to be? Now we know about squares, the actual figure of the square, that the area is equal to the side squares. So if this is 9, the square root of 9 is what? 3. So we should be able to say that each of these sides is 3. And again, I'm not putting units right now because just keep it simple. Now, if we talk about our next square over here was 16. The area of it is 16, so we know that the side lengths have to be the square root of 16, which is 4 times 4, right? So we know that 4 is the length of each of these sides right there. Now think finally about what we know about this last square, and you can help me out here and tell me for yourself. So you know that the area of this square is 25. Whatever the units may be, it's just 25. Okay, what does that mean that the length of each side has to be? So we find the square root of the area, which is 5 times 5, right? Which is 5. That's the square. I'm sorry, the square root is 5. We know then that means that each side of this square is 5. Now let's think about this. What I said before was that the area of the little square, the area of the medium square, when you add them up, is the same as the area of the big square. Well, let's try that. 9 plus 16 equals 25. Is that a true statement? It is, meaning that this area plus this area, add them up, find the sum of them, and you'll get the area of this square. Okay, following me with that, what I'm telling you now is here's Pythagorean theorem. He says that a squared plus b squared equals c squared when talking about any triangle. And what that means is that each of our squares has side length. So for the little square, our side length was 3, correct? So we'd say 3 squared plus our middle and medium sized square, the side length was 4. So we'd say 4 squared. Then we'd say equals, and then our big square, the side length we said was what? 5. 5 squared. So this is Pythagorean theorem. He says that this side squared plus this side squared equal this side squared. So here let's look at our right triangle right here. This works for only right triangles, by the way. For this right triangle right here, we understand that we have a leg and a leg. We have our little leg and our long leg. Then we have this long side of any right triangle, that's the side called the hypotenuse. New vocab term. Hypotenuse is the long side of a right triangle, okay? Now what we're saying is, let's call this one A, this one B, and this one C. So remembering Pythagorean theorem, we're saying that the side length A squared plus the side length b squared, when you find the sum of those two, they equal the side length of c squared. Let's try that out. So we have our two legs and then our hypotenuse. Two legs have been given to us for this right triangle as side length 6 and 8. What we're trying to find is our c, which is our, what was it called? Yeah, it was the hypotenuse. Okay, so remember that we said a squared plus b squared equals c squared. Okay, a, there's our 6. So we would say that 6 squared plus b, which is 8, therefore we'd say 8 squared equals, and what we don't know is c, so we say c squared. Now we go and figure them out. Well, what is 6 squared? 36, good job. What is 8 squared? Good, again, 64. What does 36 plus 64 equal? Awesome. Now, don't quickly all of a sudden say, okay, so that means this is 100. Catch, remember it said that this squared plus this squared equals this squared. That means what we've got right here, 100 is actually c squared. So what do we need to do now? We would say that c squared is 100. So to get c by itself, we need to find the square root of it. So we find the square root, we'd say that c, because remember this means c times c is the square. So the square root of c squared, which is c, the square root of 100 is 10. So that means that our side right here is 10. So let's do another right here. And I've got a right triangle. Now, important to note that all right triangles need to have this little boxed in corner right there. That signifies that it is a right angle, therefore a right triangle. Okay, I've got some side lengths here. One is missing, and that's what we're trying to find out. Now, what you have to ask yourself is, do I have A, B, and C? No. I have two of them. I have, is it A and B, and I'm trying to find C? Now, look at this triangle for a second. What are my two short sides, and what's my longest side? This side is clearly one of the short sides. Now you have to ask yourself, is this or is this the longest side? I'll give you a hint. The hypotenuse is always the side opposite from the right angle. In every single right triangle, it is this side opposite. Okay, that means that this is our hypotenuse, which is what? Which letter? If we have A, B, and C, what was our hypotenuse? Our hypotenuse was c squared. Our side length we do have is we can say a squared plus b squared. We can substitute in this 6. We can put that for either one and it doesn't make a difference. But let's say we put it in as 6 squared plus b squared equals 9 squared. Okay, now let's go ahead and solve that. I have 6 squared, I can figure out. What is 6 squared? Now b squared I cannot figure out because I don't know what b is. But I can also figure out what 9 squared. What's 9 squared? Okay, now solving equations. Ooh, so I'm going to subtract 36 from both sides. That leaves me with just on the left b squared. 81 minus 36. Okay, now I've got this. B squared is 45. So don't tell me that this is my side length. It's not. Remember, I need to find the square root of that. Finding the square root of that, now this one's going to be a funny one. I would say let's round to the nearest tenth because that is not a perfect square. So we'll say that B is, and to round to the nearest tenth, we'll call that 6. Now, remember what I said before. Let's find what it's in between. It's between 6 and 7 because the square of 6 is 36. The square of 7 is 49. So we know it's in between 6 and 7. To the nearest tenth, I would say that's 6.7. That is 6.7 inches is our side length. Now, I know this is a little confusing, but I promise with time you'll feel much better about it.